What is up, guys? Welcome back to another GeekaWhat video. In this one, I'm going to be showing you how to build the best sub $900 gaming PC you can build right now. I'll be utilizing the AMD Radeon RX 7600, a brand new card that ushers in the very first of the next generation budget GPUs. I'll be taking a look at the best parts to pair up with the RX 7600, looking at the performance you can expect from this card and a sub $900 budget, and evaluating whether the 7600 falls foul to the same mistakes as Nvidia's 4060 Ti. Let's do this. The Corsair Xeneon Flex provides the ultimate large form factor OLED gaming experience, with a massive 21:9 45-inch panel that bends from being fully flat to up to 800R. There is nothing else like it. The 3440 by 1440p resolution is sharp, while the 240Hz refresh rate makes this a great option for competitive gamers. Learn more about the Corsair Xeneon Flex at the Corsair web store, linked down in the description below. Let's begin by taking a look at the GPU first, and this particular Gigabyte gaming OC model of the 7600. Now, this is a card that aims to compete with Nvidia's 60 tier of GPUs. Of course, their recently released 4060 Ti, which costs considerably more than this, and the upcoming and cheaper RTX 4062. The 7600 has an MSRP that starts off from just $269, making it one of the cheapest GPUs released in years, literally. Certain cooler designs with extra fans and bigger form factors like this Gigabyte model may cost a bit more. This one only adds around $10 or £10 to the overall cost. Pretty reasonable if you ask me, and if recent GPU releases are anything to go by, I wouldn't see this card drop to the $250 price point, or maybe even lower in the weeks and months to come. This card is at home when it comes to 1080p, and we'll be looking at detailed performance metrics later. The 8GB of onboard video memory might not quite be enough for 1440p, as we saw with Nvidia's recently released 4060 Ti, but at the $269 price point, it's a much easier pill to swallow than with that aforementioned new Nvidia release. I've got a massive amount of respect for AMD for releasing a budget-oriented GPU. If one manufacturer doesn't start bringing prices down, the other doesn't have the incentive to follow. So good work, AMD, I like it. Now, in order to test the proper performance of this and actually get a system assembled with a GPU like this, we need to pick some good parts to go along with it. And that's where the rest of the components in today's build come into play. I have opted for an Intel platform in this build, but let me walk you through your Intel and AMD options. On the Intel side, you've got the i5-13400F, which will provide plenty of CPU power for our 7600, with a whopping 10 cores and boost clock speeds well in excess of 4 GHz. Of course, for an Intel build, you'll then want an Intel platform motherboard, either a B660 or B760 design. New cheaper motherboards are coming, like this Gigabyte B760M Gaming X DDR4. It's got all the basic features that we could need, with 4 RAM DIMM slots using the slightly cheaper DDR4 memory standard, PCI Gen 4 for your GPU and M.2 SSDs, and a decent I/O, which includes high-speed USB-A and a high-speed USB-C port. Now, if you're looking to go the AMD platform, you can either pick up their new 7600 processor with one of the cheap A620 motherboards, or go for something like a Ryzen 5 5600X from the last generation and grab yourself an end-of-life deal. Loads of options here, but as I say, the Intel Core i5 is the spec I've gone for in today's build, and links to everything mentioned will, as always, be down in the description below. In terms of the RAM or the memory for this system, I've opted for a 32GB kit of Corsair's Vengeance RGB Pro SL. DDR4 and DDR5 memory is getting seriously cheap, making building a system right now cheaper than it's been in a long while. I'll also be adding in the Corsair MP600GS. Now, while this drive is a 2TB model, I'd recommend the 1TB variant for this system. It keeps the lid on costs coming in at under $60 while still providing 1000 gigs of super speedy Gen 4 NVMe capacity. Gen 5 drives are on the way, but we don't need anything like the levels of speed they can provide for this build, and you're still going to get super snappy Windows boot times with a drive like this one. Now then, I think we should go ahead and get everything installed into the motherboard, build up the motherboard assembly bit by bit. Installing an Intel CPU is actually pretty easy and basically the same as installing a modern AMD CPU too, now that all of the pins have moved onto the motherboard for both manufacturers. Lift up your socket, line up the triangles, and drop the CPU into place. You may find it appropriate just to give it a little bit of a wiggle, make sure it's nicely seated, push your cover down, the black plastic will pop off, and then you can return everything into place nice and securely with the retention arm. I'm also going to pop the RAM or the memory in at this stage. Go ahead and locate the notch on the memory. So you've got a notch just here, and this is going to match up with the notch on the DIMM slot. The grey slots are the ones you want to use for this build to best take advantage of dual channel memory capabilities. Dual channel memory configurations do give you that bit more bandwidth, which can be really, really helpful in gaming scenarios. Nice and easy. While we're here, we're also going to pop in the M.2 NVMe drive. So that's going to go just under this heatsink. In order to do this, you simply want to unscrew the heatsink or heat spreader itself, take that out, before sliding the M.2 drive into the slot. Sort of at a 45-degree angle like this, get it in there, push it down nice and flat, and add the heat spreader back into place. The heat spreader will then screw back into the standoff the M.2 drive is rested on, holding both the heat spreader and the NVMe drive into their slot. You may be wondering at this stage what kind of cooling solution I'm going to opt for, and with this being a super budget build, I am going to stick with the Intel stock cooler. Trust me when I say that this cooling method will be more than adequate for a build like this one. The i5 is a chip that doesn't produce all that much heat, and because we won't be overclocking, it's going to be totally fine. Align the cooler just like so, and then clip in each of the 4 plastic posts. Run the fan cable up to the CPU fan header just below the middle top standoff hole, and you're all good to go on the cooling front. When all's said and done, you should then have yourself a completed motherboard assembly, which actually looks pretty good and is ready to be moved over into the case for this system. I've opted to pick up this budget micro ATX Cooler Master solution, but basically any nice chassis of the M-ATX form factor for this build will work great. You want to go for something with a tempered glass side panel, a couple of included fans, and ideally a mesh front panel if you can. The mesh front panel is going to aid massively when it comes to airflow and keeping temperatures nice and low. It's for these reasons that this Cooler Master CMP320 works perfectly for the build today. Now, you can't just go ahead and go all gung-ho screwing the motherboard into the case. There are a few things that you need to check first. Start by taking the motherboard and locating each of the holes through the board. These are what we call our standoff retention holes. You need to make sure that where each of these holes is placed on the motherboard, there is a corresponding standoff in the case. In reality, that means a total of 8 standoff screws. So 3 at the top, which look to be all in the right locations, 3 along the middle, nearly there, but we're missing 1 in the very center, and 2 towards the bottom. So just 1 standoff missing that I'm going to go ahead and screw in now. The extra standoffs, by the way, come included in an accessory box with the case you choose. This motherboard does benefit from a built-in I/O shield. Not all budget motherboard designs will, and that means it's then a simple case of sliding the board into place, lining up over all of those standoff holes, and screwing the board down. So 3 at the top, 3 along the middle, and 2 down towards the bottom. Complete our 8 screws that hold the motherboard into place. And yes, technically, if you want to skip a couple, you can. Although that isn't the official advice. The next order of business then is installing the 7600. This is the bit I'm actually very, very excited for. In an age of expensive GPUs, it is nice to see something that bit more affordable. And I love the fact that Gigabyte have produced what is, for all intensive purposes, the kind of cooler you might expect on a much more pricey card for very little over the asking MSRP price point. Now, with this being a cheaper case, it has these not particularly nice snap-on or snap-off PCI covers. And because I've used it before, I've already snapped them off, and you can't snap them back on. So we're going to have to roll with it. We can push back the clip on the PCI slot, this one just here, make sure that's nice and loose, slide the card into place, plenty of room for this pretty modest GPU really in our chassis today. A bit of pressure and it will click nice and easily in. I am going to add in a couple of screws just to stop obviously the GPU wobbling about, and then we can round things off in terms of getting this system built with the power supply afterwards. For this task, I've selected this, the Corsair CX650F. I used this recently in a 4060 Ti build. I've always liked this power supply. It's very, very similar spec-wise. I'd argue underneath it's probably identical to the Corsair CX650M, so I'll link that as a good alternative too. But it's fully modular, meaning you only plug in the cables you need. That helps to keep cable clutter to a minimum and also make sure, really, that this system is nice and easy to build, especially for first-time builders. I'll be plugging in a GPU power connector. This has got 2 8-pin harnesses. We're only going to need the 1, so we'll plug that one in down here. Alongside the largest, this is the 24-pin motherboard power cable, which is going to, of course, give our motherboard power and by virtue, feed a bit of power elsewhere in the system as well. A SATA power harness is also worth plugging in. This is going to power up any RGB controllers, any sort of old-style hard drives or old-style SSDs you might have, as well as a 4+4-pin CPU power connector. This is going to, of course, give the CPU some dedicated power via via the motherboard, making sure we've got plenty of wattage to go around. This case also has a nice bit of mesh on the underside, allowing us to install the power supply a little something like this. And what this does is it actually isolates the power supply, meaning it only pulls in its own fresh air from under the case and exhausts it out the rear. It's not pulling in the hot ambient air from the rest of the system. It's then a simple case of just plugging the cables up the other end. So the motherboard one goes just here to the top right hand side of the motherboard. CPU power comes next, and that is of course our 8-pin, which goes to the top left of the motherboard. Plug that in. Also going to add in the graphics card power cable at this stage, which will go hopefully just up here under the GPU itself, and we'll plug into the side of the graphics card here, nice and simply. And with that, power-wise, I think we're all good to go. The next thing really is to grab a monitor, a keyboard and a mouse and see if I've done a good job. Is it going to boot first time? And more importantly, how's the performance going to look like once it's all into Windows? So here goes nothing. Let's press the button. Is it going to turn on? No. I think what's happened is I've wired up the front panel connection wrong, so let me jumpstart the right ones and see if that works. Yes, okay, that's spinning. At least one of the fans is spinning. I think I'm missing a SATA power connection at the back. That's another one. Beautiful, so the front two are now on, and in theory, we should get a post signal to the monitor any minute. Oh, it's gone off. Back on. This is so tense. Feels like it's doing something, but I'm not sure if it's a good thing it's doing. Come on now, come on, come on. Yes, oh my God, it's working. It's actually working. What a time to be alive. And we're into Windows. So there's only one thing left to do. Well, two things. First, check out performance of how this card stacks up in all the latest titles. But before that, see how good this thing looks in an epic GeekaWhat montage. I'll rejoin you in just a second. It's now time to answer the question you've all been waiting for. How well does this system perform, and more specifically, just how good is the Radeon 7600? Well, I tested a wide variety of the latest titles at 1080p and 1440p. This is a card that's undoubtedly aimed more at the 1080p than 1440p resolution, and the 8GB of video memory, while in my view perfectly adequate for 1080p, does hold this card back at that higher 1440p resolution. Let's start, shall we, by looking at Apex Legends. Not the hardest game to run, but very popular nevertheless. At 1080p, the 7600 racked up an impressive 189 frames per second on average. This is a few frames per second more than the last gen 6650 XT, a card that launched retailed for $400 and falls just short, but only very marginally, of the more expensive 6750 XT, a card that when it first landed retailed for $500. It also falls not too far behind the 8GB 60 Ti, which is impressive for a card that costs $100 less. Move through to 1440p, and the Radeon 7600 sits at the slightly lower end of the graphs today, but still provides a very respectable result. 145 FPS is 15 frames more than the 6650 XT, and not far off the 3060 Ti from last generation. This is the first evidence really of that 8GB VRAM buffer holding the card back at 1440p, and I would consider those looking to build a 1440p build on a budget consider the more pricey 6750 XT with its higher amount of VRAM. Battlefield 2042 was a slightly different story. 1080p, high settings with DLSS or FSR set to performance mode on all of our AMD and Nvidia cards, and the 7600 provided a fantastic showing. It beat out the 6650 and 6750 XT, very impressive, and knocked on the door of last gen's 3070. 1440p and the card slips down the order somewhat, but still provides level pegging performance with the 6750 XT and beats out cards like the 3060 and 3060 Ti for significantly less cost. Move through into a game like Fortnite, where we've tested just about every card under the sun, and the 7600 once again impresses. 273 FPS puts it pretty much level pegging with the 6800 XT from last generation, and well outperforms all of its current Nvidia rivals. In older but popular titles like GTA 5, the 7600 also holds its own. 1080p, for example, it brings in 175 FPS, more than the 4060 Ti launched just a couple of days ago, while at 1440p it delivers a respectable 168 frames per second, punching well above its weight category. Other titles like Hogwarts Legacy also show a good set of results. We've tested not quite as many cards in this title as others due to its recency in terms of release, but the 7600 performs exactly the same frame rate wise as a 4070 and beats out the 4060 Ti at 1080p. Games like Overwatch 2 also show the 7600 with plenty of power. While it falls behind the 6650 XT in this title, it still delivers more than enough frame rate with 221 FPS on average. That's a whopping 70 frames per second more than the 3050, arguably its closest like-for-like Nvidia rival in terms of price point and market positioning. 1440p it does struggle a bit more, falling behind the likes of the 3060 Ti and last gen's 6800. Of course, the 8GB of video memory on this card will hold it back to a degree and pens it in more closely to 1080p gaming. That isn't so much of a problem as it was on the 4060 Ti, given the fact this card only cost $269. We also tested out a bit of Spider-Man Miles Morales 1440p high once again, and the 7600 provided identical performance to the 4060 Ti, a card released a couple of days ago with a $100 price bump over this AMD rival. Warzone 2 also did well, 1080p high settings, and the 7600 delivered a very strong 136 FPS once again, and you can see a pattern occurring here, not far behind the more pricey 4060 Ti and ahead of last gen's 6700, 6750 and 6650 XT tier of GPUs. Move through into 1440p and this $299 card once again blows me away. It provides level pegging performance with the 6750 XT and 4060 Ti with 121 FPS in this title. To round things off, I also tested out a little bit of Formula 1 2022 at 1080p using the ultra high preset. This is a game where Nvidia do seem to pull a bit of a lead. You can see here the 4060 Ti well outpacing the 7600, but the fact that I'm comparing these two cards in the first place shows just how good this 7600 GPU is. Move up to 1440p and you can see it struggle that little bit more. It's at the lower end of our graph test today, primarily I would imagine due to the lack of video memory, just 8GB on this model. So what do I think then of the 7600? I think that in terms of 1080p gaming, this is an exceptional value proposition, and if anything that the 7600 is a victim of its own performance success in some ways. If it didn't punch so heavily above its weight at 1440p, the VRAM conversation wouldn't be as strong as it is. But it is worth noting that those of you looking to play AAA titles, especially at 1440p in the future, should consider spending a little bit more on the 6750 XT, a card that, by the way, AMD should be commended for in terms of how much they've reduced the price and how attainable they've made many of their current and next-gen GPUs. The 7600 then, a fantastic bet for 1080p gaming, but proceed with caution if you're looking to game primarily at 1440p. I'll leave links to everything mentioned today, including the 7600, down in the description below. Thanks for tuning in, and as always, we'll see you in the next one.